Good afternoon. My name is Matovski, and today I'll talk to you about the effect of time on the performance of gait biometrics. Gait has few important advantages over other forms of biometric identification. The main ones are it's available at a distance when other biometrics are obscured or at low resolution. It's non-intrusive and it's hard to conceal. There has been a continuous rise in the number of security and surveillance cameras in effort to improve safety and security. These systems are, however, yet to include recognition capabilities. The unique advantages of gait that I just mentioned make gait very suitable for these systems. So potential applications for gait biometrics would be surveillance, security, forensics, immigration, medicine, and so on. This here, at the bottom left, is a real life example how gait was used to convict this criminal from Bolton based on his distinctive walk. So, the potential for gait biometrics is great, but in the literature, many studies have expressed concern about the effect of certain covariates on the performance of gait recognition. Examples of covariates for gait recognition are viewing angle, change of clothing, change of shoes, walking surface, and elapsed time. And there is consensus in the literature that the time taken between recording the gallery and the probe affects recognition performance the most. So an important question arises: is it possible to recognize somebody reliably after a certain period of time has elapsed? And a biometric trait that changes significantly over time is unlikely to be used for recognition. So in this talk, I'll try to answer this question here. We've looked at some previous studies, and although there is no study focusing solely on the effect of time, some studies have mentioned it in passing in a way. So there have been studies on the following data sets, and this is the recognition performance they've achieved after a period of 3 or 6 months have passed. They all have similar number of subjects, about 20 or 30, and the time period is about 3 to 6 months. So for example, on the human ID database, which is probably one of the most famous database, from about 78%, the recognition rate dropped to about 10% after 6 months. So, and there's lots of studies out there, they just focus on the same day. And there's also studies which try to solve the problem of time, similar to people trying to solve the problem of aging in face. So we hypothesize that period of 3 or 6 months is not enough to, is unlikely to have a great impact on the way we walk. So in this talk, I'll present empirical evidence to show that by controlling clothing and other covariates that are known to affect recognition, the recognition performance is not drastically affected over 9 months. And this is the longest period considered for gait so far. So the main importance of this paper is to challenge the current view that time is a problem for gait recognition. We also aim to direct the research community towards solving other covariates which affect recognition much more than elapsed time. So we've shown that clothing, for example, affects recognition much more than elapsed time does. We found that a major obstacle for the conclusion that time affects recognition is the lack of suitable databases. So we've created a novel database to be able to investigate the effect of time. And we've also shown that the ability to do recognition at the distance, which is the prime advantage of gait, is not affected by elapsed time. So now I'll tell you something about our novel temporal database. What you see here is the University of Southampton multi-biometric tunnel. It consists of 12 synchronized cameras to capture the way you walk, and it has one face camera and one ear camera. We don't use those in this experiment. We've asked our subjects to wear a boiler suit, overall So it's there. We've asked them not to wear shoes, and we've controlled the lighting and the background. So with this database, it's possible for the first time to compare samples of the same subject in the same environment, and the only thing between these two samples is they're taken at different time. Everything else remains the same. So it's possible to quantify the effect of time for the first time. Here we have on the same day